The Apollo 13 crew was 136,000 miles from Earth when a faulty electrical wire caused one of the two oxygen tanks to explode. And the now infamous words radioed back to NASA.
Okay, Houston, we've had a problem here.
To work the problem, NASA engineers tested oxygen-preserving and power cycling procedures on a replica of the Odyssey spacecraft. Apollo 13 would have ended in disaster if not for the fully functional replica on Earth. This was an important moment. NASA realized the power of the replica, but not everything can have a physical twin. So NASA coined the term digital twin, a living virtual representation of something physical. Extended to vast scales, a digital twin is a virtual world that's connected to the physical world. And in the context of the internet, it is the next evolution. And that's what NVIDIA Omniverse is about. Digital twins, virtual worlds, and the next evolution of the internet. Over 20 years of NVIDIA graphics, physics, simulation, AI, and computing technologies made Omniverse possible. Simulating the world is the ultimate grand challenge. Omniverse is a simulation engine of virtual worlds. Omniverse worlds are physically accurate, obeying the laws of physics. Omniverse operates at vast scales. And Omniverse is shareable, connecting designers, viewers, AIs, and robots. Could you imagine a world where there was no way to share documents because the content is too big, because the workflows are too complicated, and yet each document requires hundreds and hundreds of human hours to do? Well, we have, for Word documents, we have Google Docs. Well, for 3D content creation, we have nothing. We have nothing. And so we wanted to create a tool that made it possible for studios around the world to collaborate for the workflow, the designers of a single workflow, which has all these different tools and all these different steps to be able to collaborate. We've been working on this for some time, and I want to show you this great new technology from our company. It's called the Omniverse. The Omniverse basically connects up all of the designers and studios. It works with every tool. We communicate with all the tools through their plugins using USD and using MDL. And we only exchange all the things that are dynamic, and we put it into this world, this portal that everybody can see from. And so as a result, irrespective of what tool or what part of the workflow you're working on, you will see one version of the final content that you're creating in its highest possible fidelity. You could be on a laptop. Maybe your computer doesn't have ray tracing. Maybe you're using a particular tool. Its render is not quite up to the point of being able to do ray tracing. But all of you are working together in one workflow, and everything looks beautiful. Everybody has one common understanding of what everybody is working on at that moment in time. It's an open collaboration tool. It works with all of the major 3D tools out in the world. We're getting great support. People are so excited about this. Let's talk about Omniverse. The internet changed everything is surely an understatement. We are always connected now. The internet is essentially a digital overlay on the world. The overlay is largely 2D information: text, voice, images, video. But that's about to change. We now have the technology to create new 3D virtual worlds or model our physical world. These virtual worlds will obey the laws of physics, or not. There can be AI or friends with you. We will jump from one world to another, like we do on the web with hypertext. This new world will be much larger than the physical world. We will buy and own 3D things, like we buy 2D songs and books today. We will buy, own, sell homes, furniture, cars, luxury goods, and art in this world. Creators will make more things in virtual worlds than they do in the physical world. We built Omniverse for builders of these virtual worlds. Some worlds will be built for gathering and games, but a great many will be built by scientists, creators, and companies. Virtual worlds will crop up like websites today. Omniverse is futuristic. Omniverse can connect design worlds. Things created in the Adobe world can be connected to those in the Autodesk world through Omniverse, enabling designers to collaborate in a shared space. Changes by a designer in one world are updated for all connected designers, essentially like a cloud-shared document for 3D design. Omniverse will revolutionize how the 40 million 3D designers in the world collaborate. Companies can build virtual factories and operate them with virtual robots in Omniverse. The virtual factories and robots are the digital twins of their physical replica. The physical version is the replica of the digital, since they're produced from the digital original. Omniverse digital twins are where we will design, train, and continuously monitor robotics factories and buildings, warehouses, and cars of the future. Omniverse is a platform for industrial digitalization that bridges digital and physical. It lets industries design, build, operate, and optimize physical products and factories digitally before making a physical replica. Digitalization boosts efficiency and speed and saves money. One use of Omniverse is the virtual bring-up of a factory, where all of its machinery is integrated digitally before the real factory is built. This reduces last-minute surprises, change orders, and plant opening delays. Virtual factory integration can save billions for the world's factories. The semiconductor industry is investing $500 billion to build a record 84 new fabs. By 2030, auto manufacturers will build 300 factories to make 200 million electric vehicles. And battery makers are building 100 more mega factories. Digitalization is also transforming logistics, moving goods through billions of square feet of warehouses worldwide. Nearly 300,000 creators and designers have downloaded Omniverse. Omniverse is not a tool, but a USD network and shared database, a fabric connecting to design tools used across industries. It connects, composes, and simulates the assets created by industry-leading tools. We are delighted to see the growth of Omniverse connections. Each connection links the ecosystem of one platform to the ecosystems of all the others. Omniverse's network of networks is growing exponentially. Bentley Systems Lumen RT is now connected. So are Siemens Teamcenter, NX, and Process Simulate. Rockwell Automation Emulate 3D, Cesium, Unity, and many more. Let's take a look at how Nissan has integrated Omniverse into their workflow. And it's all because it's connected by all these wonderful tools and these developers that we're working with. Take a look.
The world's industries are accelerating digitalization with over $3.4 trillion being invested in the next 3 years. We at BMW strive to be leading edge in automotive digitalization. With NVIDIA Omniverse and AI, we set up new factories faster and produce more efficiently than ever. This results in significant savings for us. It all starts with planning, a complex process in which we need to connect many tools, datasets, and specialists around the world. Traditionally, we are limited since data is managed separately in a variety of systems and tools. Today, we've changed all that. We are developing custom Omniverse applications to connect our existing tools, know-how, and teams, all in a unified view. Omniverse is cloud-native and cloud-agnostic, enabling teams to collaborate across our virtual factories from everywhere.
Amazon Robotics has manufactured and deployed the largest fleet of mobile industrial robots in the world. The newest member of this robotic fleet is Proteus, Amazon's first fully autonomous warehouse robot. Proteus is built to move through our facilities using advanced safety, perception, and navigation technology. Let's see how NVIDIA Isaac Sim, built on Omniverse, is creating physically accurate, photoreal simulations to help accelerate Proteus deployments. Proteus features multiple sensors that include cameras, LiDARs, and ultrasonic sensors to power its autonomy software systems. The Proteus team needed to improve the performance of a neural network that read fiducial markers and helped the robot determine its location on the map. It takes a lot of data, and the right kind, to train the ML models that are driven by the robot sensor input. With Omniverse Replicator in Isaac Sim, Amazon Robotics was able to generate large photoreal synthetic datasets that improve the marker detection success rate from 88.6% to 98%. The use of synthetic data generated by Omniverse Replicator also sped up development times from months to days as we were able to iteratively test and train our models much faster than when only using real data. To enable new autonomous capabilities for the expanding fleet of Proteus robots, Amazon Robotics is working towards closing the gap from simulation to reality, building large-scale multi-sensor, multi-robot simulations. With Omniverse, Amazon Robotics will optimize operations with full-fidelity warehouse digital twins. Whether we're generating synthetic data or developing new levels of autonomy, Isaac Sim on Omniverse helps the Amazon Robotics team save time and money as we deploy Proteus across our facilities.
The world is racing to build state-of-the-art, large-scale AI factories. Bringing up an AI gigafactory is an extraordinary feat of engineering, requiring tens of thousands of workers from suppliers, architects, contractors, and engineers to build, ship, and assemble nearly 5 billion components and over 200,000 miles of fiber, nearly the distance from the Earth to the Moon. The NVIDIA Omniverse blueprint for AI factory digital twins enables us to design and optimize these AI factories long before physical construction starts. Here, NVIDIA engineers use the blueprint to plan a 1 gigawatt AI factory, integrating 3D and layout data of the latest NVIDIA DGX SuperPods and advanced power and cooling systems from Vertiv and Schneider Electric, and optimized topology from NVIDIA Air, a framework for simulating network logic, layout, and protocols. This work is traditionally done in silos. The Omniverse blueprint lets our engineering teams work in parallel and collaboratively, letting us explore various configurations to maximizing TCO and power usage effectiveness. NVIDIA uses Cadence Reality Digital Twin, accelerated by CUDA and Omniverse libraries, to simulate air and liquid cooling systems. And Schneider Electric with ETAP, an application to simulate power block efficiency and reliability. Real-time simulation lets us iterate and run large-scale what-if scenarios in seconds versus hours. We use the digital twin to communicate instructions to the large body of teams and suppliers, reducing execution errors and accelerating time to bring up. And when planning for retrofits or upgrades, we can easily test and simulate cost and downtime, ensuring a future-proof AI factory. Every robotics company will ultimately have to build 3 computers. The robotic system could be a factory, the robotic system could be a car, it could be a robot. You need 3 fundamental computers. One computer, of course, to train the AI. We call it the DGX computer to train the AI. Another, of course, when you're done, to deploy the AI. We call that AGX. That's inside the car, in the robot, or in an AMR, or at the in a stadium, or whatever it is. These computers are at the edge and they're autonomous. But to connect the two, you need a digital twin. And this is all the simulations that you were seeing. The digital twin is where the AI that has been trained goes to practice, to be refined, to do its synthetic data generation, reinforcement learning, AI feedback, such and such. And so it's the digital twin of the AI. These 3 computers are going to be working interactively. NVIDIA's strategy for the industrial world, and we've been talking about this for some time, is this 3-computer system. Instead of a three-body problem, we have a 3-computer solution. In the case of humanoid robots, the imitation information is rather hard to collect. And the reason for that is, in the case of car, you just drive it. We're driving cars all the time. In the case of these humanoid robots, the imitation information, the human demonstration is rather laborious to do. And so we need to come up with a clever way to take hundreds of demonstrations, thousands of human demonstrations, and somehow use artificial intelligence and Omniverse to synthetically generate millions of synthetically generated motions. And from those motions, the AI can learn how to perform a task. Let me show you how that's done. Developers around the world are building the next wave of physical, AI-embodied robots, humanoids. Developing general-purpose robot models requires massive amounts of real-world data, which is costly to capture and curate. The NVIDIA Isaac GR00T blueprint for synthetic motion generation is a simulation workflow for imitation learning, enabling developers to generate exponentially large datasets from a small number of human demonstrations. First, GR00T Teleop enables skilled human workers to portal into a digital twin of their robot using the Apple Vision Pro. This means operators can capture data even without a physical robot, and they can operate the robot in a risk-free environment, eliminating the chance of physical damage or wear and tear. To teach a robot a single task, operators capture motion trajectories through a handful of teleoperated demonstrations, then use GR00T Mimic to multiply these trajectories into a much larger dataset. Next, they use GR00T Gen, built on Omniverse and Cosmos, for domain randomization and 3D to real upscaling, generating an exponentially larger dataset. The Omniverse and Cosmos Multiverse Simulation Engine provides a massively scaled dataset to train the robot policy. Once the policy is trained, developers can perform software-in-the-loop testing and validation in Isaac Sim before deploying to the real robot. The age of general robotics is arriving, powered by NVIDIA Isaac GR00T. The autonomous vehicle revolution is here. Building autonomous vehicles, like all robots, requires 3 computers: NVIDIA DGX to train AI models, Omniverse to test drive and generate synthetic data, and Drive AGX, a supercomputer in the car. Building safe autonomous vehicles means addressing edge scenarios, but real-world data is limited, so synthetic data is essential for training. The Autonomous Vehicle Data Factory, powered by NVIDIA Omniverse, AI models, and Cosmos, generates synthetic driving scenarios that enhance training data by orders of magnitude. First, OmniMap fuses map and geospatial data. to construct drivable 3D environments. Driving scenario variations can be generated from replayed drive logs or AI traffic generators. Next, a neural reconstruction engine uses autonomous vehicle sensor logs to create high-fidelity 4D simulation environments. It replays previous drives in 3D and generates scenario variations to amplify training data. Finally, Edify 3DS automatically searches through existing asset libraries or generates new assets to create sim-ready scenes. The Omniverse scenarios are used to condition Cosmos to generate massive amounts of photorealistic data, reducing the sim-to-real gap. And with text prompts, generate near-infinite variations of the driving scenario. With Cosmos Nemotron Video Search, the massively scaled synthetic dataset, combined with recorded drives, can be curated to train models. NVIDIA's AI Data Factory scales hundreds of drives into billions of effective miles, setting the standard for safe and advanced autonomous driving.
Isn't that incredible? We take thousands of drives and turn them into billions of miles. We are going to have mountains of training data for autonomous vehicles. Of course, we still need actual cars on the road. Of course, we will continuously collect data for as long as we shall live. However, synthetic data generation using this multiverse, physically based, physically grounded capability so that we generate data for training AIs that are physically grounded and accurate or plausible so that we could have an enormous amount of data to train with. The AV industry is here. This is an incredibly exciting time, super excited about the next several years. I think you're going to see, just as computer graphics was revolutionized such incredible pace, you're going to see the pace of AV development increasing tremendously over the next several years.
Everything that moves will be autonomous. Physical AI will embody robots of every kind, in every industry. 3 computers built by NVIDIA enable a continuous loop of robot AI simulation, training, testing, and real-world experience. Training robots requires huge volumes of data. Internet-scale data provides common sense and reasoning, but robots need action and control data, which is expensive to capture. With blueprints built on NVIDIA Omniverse and Cosmos, developers can generate massive amounts of diverse synthetic data for training robot policies. First, in Omniverse, developers aggregate real-world sensor or demonstration data according to their different domains, robots, and tasks. Then use Omniverse to condition Cosmos, multiplying the original captures into large volumes of photoreal, diverse data. Developers use Isaac Lab to post-train the robot policies with the augmented dataset. And let the robots learn new skills by cloning behaviors through imitation learning, or through trial and error, with reinforcement learning AI feedback. Practicing in a lab is different than the real world. New policies need to be field-tested. Developers use Omniverse for software and hardware-in-the-loop testing, simulating the policies in a digital twin with real-world environmental dynamics, with domain randomization, physics feedback, and high-fidelity sensor simulation. Real-world operations require multiple robots to work together. Mega, an Omniverse blueprint, lets developers test fleets of post-trained policies at scale. Here, Foxconn tests heterogeneous robots in a virtual NVIDIA Blackwell production facility. As the robot brains execute their missions, they perceive the results of their actions through sensor simulation, then plan their next action. Mega lets developers test many robot policies, enabling the robots to work as a system, whether for spatial reasoning, navigation, mobility, or dexterity. Amazing things are born in simulation. Today, we're introducing NVIDIA Isaac GR00T N1. GR00T N1 is a generalist foundation model for humanoid robots. It's built on the foundations of synthetic data generation and learning in simulation. GR00T N1 features a dual system architecture for thinking fast and slow, inspired by principles of human cognitive processing. The slow thinking system lets the robot perceive and reason about its environment and instructions, and plan the right actions to take. The fast thinking system translates the plan into precise and continuous robot actions. GR00T N1's generalization lets robots manipulate common objects with ease and execute multi-step sequences collaboratively. And with this entire pipeline of synthetic data generation and robot learning, humanoid robot developers can post-train GR00T N1 across multiple embodiments and tasks across many environments. Around the world, in every industry, developers are using NVIDIA's 3 computers to build the next generation of embodied AI.